5th May 1943. Hillersleben Proving Ground, Magdeburg District, Germany. The first test firing of the experimental weapon designated V6, later known as Hochdruckpumpe, or high-pressure pump, commenced at 0847 hours under overcast skies with surface winds measured at 12 kilometers per hour from the northwest, the air temperature recorded at 9 degrees Celsius, and the ground still damp from overnight rain that had turned the access roads into channels of dark mud tracked by the half-dozen Opel Blitz trucks that had delivered the technical staff and observation teams before dawn. The weapon itself stretched 150 meters along a reinforced concrete emplacement dug into the sandy earth of the proving ground, its smooth-bore barrel composed of multiple sections joined in sequence, each section fitted with pairs of angled side chambers designed to inject additional propellant charges as the projectile passed, a concept derived from multi-stage acceleration principles that Chief Engineer August Kinders had proposed to the Heereswaffenamt in late 1942 as a means of achieving muzzle velocities exceeding 1,500 meters per second without the catastrophic barrel wear that plagued conventional artillery at extreme pressures. The barrel, manufactured by Röckling Eisen- und Stahlwerke, had an internal diameter of 150 millimeters and incorporated 32 side chambers arranged in pairs along its length, each chamber packed with diethyl ether-based propellant that would theoretically ignite in precise sequence as the finned projectile traveled upward through the tube, the timing controlled by electrical firing mechanisms tested extensively in laboratory conditions, but never before at full scale with a complete weapon system. Oberst Karl Emil Metz of the Artillery Development Office stood in the reinforced observation bunker 300 meters to the southwest, his field glasses trained on the massive barrel angled at 52 degrees toward the Baltic test range, while beside him, Hauptmann Friedrich Dornberger, younger brother of the rocket engineer, consulted a stopwatch and waited for the signal from the firing team sheltered in their own concrete blockhouse adjacent to the weapon's breech. The morning had begun with a technical briefing in which Kinders had outlined the expected performance parameters, a 120-kilogram projectile achieving a range of 165 kilometers, potentially reaching targets across the English Channel if emplaced along the French coast, with a rate of fire projected at 1 round every 6 minutes, once operational crews had been trained and logistical systems established. The projectile itself, thinned and streamlined, sat loaded in the breech, its nose cone machined from hardened steel and its body containing a high explosive charge of 25 kilograms, modest by heavy artillery standards, but multiplied in strategic value by the weapon's projected range and the relative immunity from counter-battery fire that such distance would provide. At 0851 hours, the firing signal came through the field telephone line as a series of 3 short rings, and Hauptmann Dornberger marked the time while Oberst Metz raised his field glasses again, watching the barrel and the cleared impact zone beyond where range flags hung limp in the still air. The electrical firing sequence initiated with a dull mechanical click audible even at 300 meters, followed immediately by the ignition of the main breech charge, which produced not the sharp crack of conventional artillery, but a deeper, more sustained roar as the propellant gases expanded, and drove the projectile into the barrel where the first set of side chambers should have fired at the calculated moment. But the sound that followed was wrong, a cascading series of premature detonations rippling along the barrel's length like firecrackers in a chain. The side chambers igniting out of sequence as the pressure wave moved faster than the projectile, each explosion adding not to forward acceleration, but to destructive stress on the barrel sections, which began to split at the welded joints, venting superheated gas in lateral jets of orange flame that tore through the concrete revetments and sent fragments of steel casing spinning across the proving ground in flat arcs that buried themselves in the sandy soil or clanged off the observation bunker's armored shutters with sounds like hammer blows. The projectile itself emerged from the muzzle at approximately 900 meters per second, respectable by conventional standards, but far below the theoretical velocity, and traced a wobbling arc across the sky before impacting in the test range at an estimated 40 kilometers downrange. While behind it, the barrel assembly sagged and twisted, three of its central sections blown open along their seams, and the electrical firing system a smoking ruin of melted insulation and severed cables. In the observation bunker, Oberst Metz lowered his field glasses slowly and turned to Hauptmann Dornberger, who had stopped his stopwatch at the moment of the first visible failure, and neither man spoke for several seconds, while outside the emergency crews emerged from their shelters and began moving toward the wrecked weapon with fire extinguishers and medical kits. Though no casualties had occurred due to the reinforced positions and strict safety protocols that had anticipated at least the possibility of catastrophic malfunction. August Kinders arrived from the firing bunker 10 minutes later, his face gray and his hands trembling slightly as he examined the damage, walking the length of the barrel assembly while taking notes in a leather-bound logbook, pausing frequently to inspect the blown-out side chambers and the carbon scoring on the interior surfaces where propellant had burned unevenly. And by noon he had compiled a preliminary assessment that identified the ignition timing mechanism as fundamentally flawed, the electrical delays insufficient to account for the actual velocity of the pressure wave, which propagated through the barrel faster than any projectile could travel, causing the side chambers to fire into a space already occupied by expanding gases, rather than behind a moving projectile, thus converting what should have been additive thrust into destructive interference. The test range was secured and the damaged weapon photographed from multiple angles for the technical report that would be filed with the Heereswaffenamt by weekend. And as the May afternoon wore on and the clouds broke apart to reveal patches of pale blue sky, Oberst Metz authorized the assignment of additional engineering resources to redesign the firing sequence while maintaining his official assessment that the weapon showed promise despite the evident difficulties, a conclusion driven more by strategic desperation than by technical optimism. For by May 1943, the Reich's military situation had deteriorated sufficiently that even experimental weapons with dubious prospects received continued funding if they offered any theoretical advantage against targets that conventional artillery could not reach. 22 September 1943, Mimoyecques, Pas-de-Calais, France. Construction of Battery Weiss, the operational emplacement for 50 V6 Hochdruckpumpe tubes aimed across 160 kilometers of English Channel toward London, had reached 60% completion by the autumn equinox, with organization tote crews working in 3 shifts around the clock to excavate the chalk hillside and pour the reinforced concrete chambers that would house the weapons in an underground complex designed to be invulnerable to air attack. The site located 3 kilometers inland from the coast and carefully concealed beneath what appeared from aerial reconnaissance to be an ordinary quarry operation, complete with dummy equipment and deliberate patterns of activity meant to suggest industrial stone cutting rather than military construction. Oberstleutnant Georg Thomas of the artillery branch arrived at the site just after dawn in a Kübelwagen that had navigated the narrow roads from Calais, roads lined with beech trees showing the first yellow edges of autumn and rutted from the passage of heavy trucks carrying cement, steel reinforcement bars, and the massive barrel sections that arrived by rail to Marquise and then by road convoy under darkness to avoid observation by Allied reconnaissance aircraft that flew regular patterns over the Pas-de-Calais region at altitudes above 8,000 meters. The site itself had been cut into the southwestern face of a chalk ridge, the excavation descending 40 meters below ground level and extending laterally for more than 300 meters, creating a vast gallery system where the V6 tubes would be installed at angles calculated to arc their projectiles across the channel and into the British capital at a projected rate of 300 rounds per hour once all 50 tubes reached operational status. A bombardment tempo that planners in Berlin believed would prove psychologically devastating and militarily sustainable, given the weapon's expected immunity from British counter-battery fire. Thomas was met at the site entrance by Hauptmann Otto Becker, the garrison commander responsible for security and coordination with Organization Todt, and together they descended into the excavation using a wooden stairway lit by electric bulbs strung on cables that hummed with current from the diesel generators positioned on the surface, the air growing cooler and damper as they went deeper, until at the bottom they emerged into a cathedral-like space where arc lights illuminated the pale chalk walls and the dark mouths of tunnels extending in 5 directions like the fingers of a hand. The construction noise was tremendous, pneumatic drills attacking the chalk face, cement mixers grinding out their loads, the clang of steel reinforcement being welded into frameworks, and the shouts of foremen coordinating work crews that included German engineers, French laborers conscripted under service du travail obligatoire provisions, and a contingent of Soviet prisoners of war whose gaunt faces and striped uniforms marked them as expendable labor for the most dangerous tasks. Thomas and Becker walked through the main gallery, where the first 10 tube assemblies had been installed, each tube resting in its concrete cradle and angled upward at precisely 49 degrees, the calculations having been refined since the Hillersleben tests to optimize range while minimizing stress on the barrel sections, though the ignition timing problems remained only partially solved despite 6 months of additional testing and numerous redesigns of the electrical firing mechanism that still showed an unacceptable failure rate of approximately 1 catastrophic malfunction per 37 firings. The tubes themselves had been manufactured in sections by Röchling and transported from the Saarland in pieces that weighed up to 15 tons each, requiring specialized rail cars and road transporters. And the installation process involved precision alignment using theodolites and spirit levels to ensure that all tubes aimed at the correct azimuth and elevation, for even a single degree of error would translate to a miss distance of several kilometers at maximum range. By mid-morning, Thomas had completed his inspection of the installed tubes and proceeded to examine the ammunition storage chambers, where finned projectiles sat racked in wooden cradles, each projectile painted in a gray primer and stenciled with production codes from the Krupp works at Essen, and the propellant magazines, where diethyl ether charges were stored in copper cylinders under carefully controlled temperature and humidity conditions, for the propellant had proven dangerously unstable when exposed to fluctuations in environmental conditions, a problem that had resulted in 2 accidental explosions during transport and loading operations, killing 11 men in separate incidents that had been classified and omitted from official construction reports. The complex included living quarters for a projected garrison of 275 personnel, including gun crews, maintenance technicians, security troops, and command staff, plus ammunition handlers who would work in continuous rotation to maintain the projected firing rate, though actual crew training had been delayed due to the ongoing technical problems and the diversion of experienced artillery personnel to the Eastern Front, where the Wehrmacht faced increasingly desperate defensive actions following the failure of Operation Zitadella at Kursk in July. Thomas spent the afternoon in the command post, reviewing firing tables and logistics schedules with Hauptmann Becker, noting in his official report that the site would require an estimated 3,000 tons of ammunition per week to sustain planned operations, a supply requirement that would strain already overtaxed rail networks and represent a significant vulnerability to Allied air interdiction. Though the assessment also acknowledged that once operational, the battery would provide a psychological weapon of considerable value, demonstrating the Reich's capacity to strike at the British capital with apparent impunity, and forcing the diversion of Allied resources to defense and countermeasures. As evening approached and the work shifts changed, Thomas climbed back to the surface and stood for several minutes at the excavation's edge, looking out across the French countryside, where the low sun painted the fields in shades of gold and amber. And somewhere to the northwest, beyond the curve of the earth and the gray waters of the Channel, lay London, where British engineers were undoubtedly working on their own calculations and countermeasures, for the Allies' signals intelligence had certainly detected indications of unusual construction activity in the Pas-de-Calais region, even if they had not yet determined the exact nature of the weapon being prepared. The night came on with a cold wind from the sea, bringing the smell of salt and diesel exhaust. And in the excavation below, the work continued under the arc lights, the sound of drills and hammers echoing up from the chalk galleries, where hundreds of men labored to complete a weapon that represented both German engineering ambition and the increasing desperation of a strategic situation that had turned against the Reich on every front, though none of this broader context appeared in the technical reports and construction schedules that documented only the concrete problems of angles, pressures, firing sequences, and ammunition supply rates. 6 July 1944, Mimoyecques, Pas-de-Calais, France. The battery remained incomplete and non-operational when, at 12:42 hours, 6 ARO Lancaster bombers from RAF 617 Squadron, flying at 12,000 feet under scattered clouds that allowed intermittent visibility of the French coast, released a total of 19 Tallboy bombs, each weighing 5,450 kilograms and designed by Barnes-Wallis specifically for deep penetration of hardened targets, over the camouflaged excavation site that British intelligence had designated Wizay and assessed with high confidence as the location for long-range artillery threatening London. The intelligence derived from a combination of photographic reconnaissance showing suspicious construction patterns, signals intercepts indicating artillery-related activity, and reports from French resistance observers who had noted the unusual volume of heavy equipment and materials being transported to the site over the preceding 12 months. The Lancasters, each powered by 4 Rolls-Royce Merlin engines producing a combined 4,800 horsepower, had departed RAF Woodhall Spa in Lincolnshire at 10:47 hours and crossed the Channel at low altitude to avoid German radar detection before climbing to bombing altitude over the French coast, the flight led by Squadron Leader J.L. Fauquet, with bombardiers using stabilizing automatic bomb sight equipment calibrated for the Tallboy's unique ballistic characteristics, the bomb having been designed to penetrate earth and concrete before detonating deep underground with seismic effects that would collapse reinforced structures more effectively than surface explosions. The first Tallboy struck 50 meters north of the main excavation entrance, punching through 6 meters of chalk and soil before detonating with a muffled roar that sent a column of white dust and debris climbing into the afternoon sky, the explosion creating a crater 8 meters deep and collapsing 2 of the access tunnels in cascading failures that buried 3 organization tote work crews and cut power to the lower galleries, plunging them into darkness pierced only by emergency lanterns and the distant rumble of continuing detonations as subsequent bombs impacted across the site in a pattern that suggested either excellent bomb site accuracy or extraordinary luck. in the command post, located in a reinforced concrete bunker 70 meters from the main excavation, Hauptmann Becker felt the first explosion as a sharp jolt that knocked papers from his desk and extinguished the electric lights, leaving him in blackness broken seconds later when an Unteroffizier opened the blast door and pale daylight flooded in along with the sound of air raid sirens that had begun wailing from the security perimeter, though by then the bombing was already well underway and the personnel on site could do nothing but seek shelter in the deeper galleries or attempt to reach the dispersed slit trenches that had been dug around the perimeter for precisely this contingency. A second Tallboy struck the southern ventilation shaft, collapsing it completely and sending a pressure wave through the underground galleries that blew out doors and shattered the arc lights, while a third bomb impacted directly above Chamber 7, where 4 completed V6 tubes sat in their cradles, the explosion's seismic effect fracturing the concrete revetments and causing a progressive collapse that twisted the barrel assemblies and buried them under thousands of tons of fractured chalk that would require weeks to excavate even if the decision were made to continue construction, which by July 1944 had become increasingly unlikely given the Reich's deteriorating strategic position following the Allied landings in Normandy 1 month earlier. The bombing continued for 7 minutes, during which period the Lancasters made multiple passes to ensure complete coverage of the target area, their tail gunners scanning the sky for Luftwaffe fighters that did not appear, the nearest German fighter squadron at Abbeville-Drucot having been pulled back to Germany for homeland defense operations, and by 12:49 hours, the last Lancaster was climbing away to the northwest, leaving behind a landscape transformed into a moonscape of overlapping craters and collapsed earthworks from which white chalk dust rose in clouds that drifted slowly inland on the sea breeze. In the underground galleries, emergency crews worked by lantern light to evacuate wounded personnel and assess the damage, finding that while the deepest chambers had survived structurally intact, all access routes had been compromised, and at least 4 of the completed gun tubes had been damaged beyond repair, their barrel sections cracked or bent by the seismic shocks that had resonated through the chalk bedrock with devastating effect. Hauptmann Becker emerged from the command bunker at 13:20 hours to find the site unrecognizable, the carefully landscaped surface that had been maintained to conceal the construction now torn open in multiple places to reveal the galleries beneath, and casualties being carried on stretchers to the medical station where a single army doctor worked with inadequate supplies to treat crush injuries and fractures, the final count reaching 47 dead and 93 wounded, most of the casualties being French laborers and Soviet prisoners who had been working in the collapsed tunnels when the attack commenced. By evening, Oberstleutnant Thomas had arrived from Calais with orders to assess whether construction should continue, and after touring the damaged site and reviewing engineering reports, he concluded that repairs would require a minimum of 4 months and substantial additional resources that could not be justified given the current military situation, particularly with Allied forces now firmly established in Normandy and advancing toward Paris, which made the likelihood of maintaining supply lines to the Pas de Calais increasingly tenuous. The formal order to cease construction arrived from Berlin on 18 July, transmitted by teleprinter to the garrison headquarters and signed by General Oberstleut Alfred Jodl of the Wehrmacht Operations Staff. The order directing that all salvageable equipment be evacuated and the site be prepared for demolition to prevent capture by advancing Allied forces, though in practice much of the heavy machinery and the damaged gun tubes remained in place when the last German personnel withdrew from Mimoyecques on September 5, 1944, 3 months before the Wehrmacht's final offensive in the west would collapse at the Battle of the Bulge, and less than a year before the Reich's unconditional surrender. The battery that was to have hurled 300 rounds per hour into London never fired a single shot in anger, its concrete galleries serving instead as a monument to engineering ambition outpaced by strategic reality. And in the decades following the war, the site would be partially excavated by historians and curiosity seekers, who found the barrel sections still rusting in their cradles beneath tons of collapsed chalk, along with scattered ammunition and the personal effects of workers who had fled the RAF bombing. These artifacts eventually collected and displayed in local museums, where they testified to a weapon system that represented perhaps the culmination of conventional artillery development and simultaneously its obsolescence. For the future belonged to rockets and guided missiles that would make the elaborate multi-chambered gun an evolutionary dead end, impressive in concept but ultimately impractical in execution, defeated less by British bombs than by the fundamental mismatch between the weapon's technical demands and the operational realities of modern warfare.